calculator ready next to you, so it will be much better. Okay, let me share the slide. You can hear me, right? Let me share my slides. This my slide. Okay. Okay. The main topic is okay. The main topic for today is tools to improve quality and quality diagnosis procedure. This slide will cover chapter 9 and chapter 10, but in your Foster book, it will be chapter 11 and 12. Okay, if you want to refer to the book, it's chapter 11 and 12. Okay, we call it statistical quality control. Remember, it's one of the quality tools. Is what we call control charts is one of the quality tools where we find errors. Okay, we identify errors in the process. Okay. Chapter 9, so there's two chapters. We go to chapter 9 first. You look at we go for chapter 10 or chapter 9 first. Yeah, it depends. You see how the slides follow. Okay, here, remember one of the quality gurus, Koru Ishikawa, he says that data are required to obtain the average dimensions and the degree of dispersion in the process, so that we can determine whether the production process used for manufacturing the lot is suitable, or if some action must be taken. In other words, action can be taken on a process on the basis of data gained from sample. Okay, what Mr. Koru Ishikawa says that you need data. Okay, even if you do research, you will collect data. So the data that we use, that we search for, is there's is different kinds of data, but the data can determine the degree of dispersion of the process, whether the process is in control or the process is out of control. This is how we're going to find through statistical process. Okay, we use statistics. I hope that all of you have taken statistics before. I think in um, in your SPM you have learned that is, we developed by batches, whether we can take the batch to be sold, or if there's a lot of errors, we have to scrap. That means we have to throw away the whole batch, right? Okay. Here they talk about statistical thinking, pemikiran secara statistics, right? What is statistical thinking? Okay, is a decision-making skill demonstrated by the ability to draw conclusion based on data. Okay, the important thing is decision-making based on data, bukannya agak-agak, bukan rasa-rasa, your decision, okay, every decision that you make, it must be based on data. Okay, so statistical thinking is based on three concepts, right? They say that all work occurs in a system of interconnected process. Okay, the process are all interconnected, and the process have variation, variasi. Okay, so kata pula, the amount of variation tends to be underestimated. Although setiap proses ada variasi, tapi selalunya kita underestimate. Kita rasa variasi tu sikit je, tak ada masalah, right? But actually, benda tu can affect, right? Kalau kita biar saja dan tidak diambil kira, so benda tu, variasi tu akan mengacau, okay? Mengacau proses tersebut, and you can make the process to be unstable. Okay? And the third concept is understanding variation and reduce variation are important keys to success. Kita kena tahu dari mana datangnya variation tu. Kena faham how the variation occur, dan kita perlu reduce ataupun kita eliminate terus variation. Yeah? Okay? Why do some statistics sometimes fall in the workplace? Kenapa maksud dia tak menjadi? Actually, according to, kalau you are a statistician, you will say that everything you tengok dalam kacamata statistik, semua ada perkiraan dia gini. Okay? So, kenapa tak jadi? So, because lack of knowledge about the tools. Kita tak ada knowledge yang cukup untuk tahu, right, nak menggunakan statistical tools ni. Dan lagi satu, kenapa statistik tidak digunakan di tempat kerja, sebab kita dah ada perception yang mathematics ni susah. Okay? Dengan math je semua susah. Because we already have the perception, dia menjadi satu halangan, dia menjadi satu barrier untuk kita. Right? Just to say, kadang-kadang kita ni once, tak kira lah statistik ke apa, if you are given something, okay, you are given homework ke, you are given a task by your parents ke, the first thing selalunya lah, in general, mungkin it doesn't apply to you. In general, kita fikir, alah susahnya. Once you form that perception, you are telling yourself, you tak boleh nak buat. Susah lah, memang tak boleh buat lah. So kalau macam selalunya, if you are given something, okay, I'm given this thing, how to do it? Why this thing happen? That kind of question yang sepatutnya it will be in your mind. Then you develop what? Bila kalau you ada curiosity, okay? Kalau you ada questions in your mind, then you can do the job. Kadang-kadang bila kita rasa Allah susahnya, lepas tu bila buat sikit je pun, kan? Kalau buat daripada dulu dah siap dah. Usually it's like that. Okay? Ni sebab kita natural. Barriers of math ni bukan di Malaysia je, di mana-mana. Yeah? Orang apa? Ada orang memang dilahirkan memang dia pandai math. Ada orang bukan dia tak pandai, dia takut math. Dengan math saja tak boleh nak buat. Sedangkan kalau mathematics macam ni, for SPC ni, selalunya kalau masuk exam dia paling senang nak score. Because once you get everything right, you get to full marks. Selalunya soalan 20 markah kan. You can get easy marks lah, dapat 20. Kalau macam if you doing macam theories ke apa, boleh lah. Sometimes the lecturer can tengok how you say it kan. Tapi kalau math ni, kalau you betul, memang betul. You get 20 marks full. Right? Okay, back to statistik. Kita lari sekejap. Right. Tadi kan konsep dalam statistik tu, they say processes involve variation. Memang ada variasi. Okay? Some variation can be managed and some cannot. Macam let's say if you are a tailor kan, you tukang buat baju. Kalau you gunting baju pun mesti ada variation kan. It won't be on the dot. Ada mungkin you tak nampak ke 1-2 milimeter terbesar atau terkecil. That means every process there is a variation. Okay? If too much variation, the process will not fit correctly. Okay? Kalau macam jahit baju, sikit-sikit tu still okay lah. Right? Tapi kalau variasi dia besar sangat, sampai 2-3 inci, that means it will not fit perfectly. Okay? Product not function properly and firms will get bad reputation or image. Macam if you are making a screw, screw tu kan ada lubang dia, bulat dia tu, that dimension, lepas tu dengan yang screw yang nak masuk, yang rod yang nak masuk ke dalam bulatan tu kan nak masuk tu, so dia kena the right size. Kalau ada variation pun mungkin 1-2 milimeter, not sentimeter ya, 1-2 milimeter tu still okay. Kalau dah besar dia, that means screw tu tak boleh guna dah. Right? So here we want to look at variation. Variation ada dua. There's two types of variation. One is random variation and one is non-random variation. Okay? Random variation ni you can't control. Right? You can't control. Usually it is centered around the mean and occurs with a somewhat consistent amount of dispersion. Right? The amount of random variation boleh jadi besar ataupun kecil. Okay, you look at the picture here. There's the, right? Then there's tiba-tiba ada variation. Okay? Non-random. Non-random variation tiba-tiba dia tak tidak macam tidak selalu occur. Dia akan occur in maybe because of a certain event. Okay, the event may be shift in the process, mean or some unexpected occurrence. Okay, stable process, lepas tu tiba-tiba ada satu pula ke belakang ni, yang tengah-tengah ni tak ada. So, apa yang kita nak tengok from SPC ni, kita nak identify non-random variation. Ya? Yeah? Random variation tu kita tak usik dah, pasal kita tahu dia is memang kita tak boleh control random variation. Right? Means that the variation you observe in the process, kita akan tengok random and non-random. Tapi kita nak decide whether the process is stable. Right? Process charts are graph designed to process workers, to show process workers when non-random variable is occurring in the process. So kita tengok kenapa tiba-tiba dia punya variasi jadi jauh ke atau tidak dalam mean ke kan, dia keluar kepada average. So dalam proses chart ni we use data yang kita collect dan kita map out to find out if the process is in control ataupun proses dia stable ke tidak. Remember, kita nak identify non-random variation, bukannya random variation. Okay, process control charts is a method for monitoring a process. Kan, kita proses kan panjang, so it's a method to monitor sama ada supaya kita punya proses tu tidaklah salah terlalu lama, kan? Kalau macam kita buat manufacturing, kita tak tengok Sekali dah lepas 1 hari tengok, rupanya ada banyak non-random variation. Jadi apa yang kita produce for that day, kena buang. Right? So, kalau kita dah jumpa non-random variation, we have to take corrective action. Kita kena macam mana nak reduce the non-random variation. Kita tengok ya. Remember, one of the quality tools tu is histogram, right? This is what we're going to do, the control charts. Histogram ni, dia tunjuk, ni error, tapi dia tak tunjuk bila, when it happens, at what point it happens. Kalau kita guna control charts, then we can see, start from sample 15 ni, dia dah start dah and going differently. So kita tengok what causes, apa yang menyebabkan jadi macam tu. Control chart application, establish state of statistical control, kita monitor dan kita determine sama ada proses tu capable or not. That is the application of control charts. Kenapa kita tak guna control chart? Process capability calculation make little sense if the process is not statistically controlled. Because the data are confounded by special causes that do not represent the inherent capability of the process. Sebelum kita cari process capability, kita kena make sure that dia ni kena in control. That means kita dah dapat mengurangkan atau menghilangkan non-random variation. Right? Faham tak? Everybody okay? Still okay ke? You all dah tidur dah? Ke I sorang-sorang dia cakap kat sini? Are you sure you all are there? Ke semua kerik-kerik je? Okay, still okay. Right? Okay, still here. Good. Right. Okay. This at least in quality management, you must, lepas you habis kelas quality, at least you know what is SPC. Okay, SPC, Statistical Process Control. Right? So because this is used to check the quality of a product or service. Right? So it monitors the production process to prevent poor quality. And then you take a certain sampling. Usually kalau kita nak check, we don't check the whole product, the whole population. Kita ambil acceptance sampling to make sure that all the whole lot lah, the whole batch that we produce tu is acceptable. Sebab bila dia buat ni beribu-ribu, okay, they don't, especially in factory, bukannya dia buat 100 ke 1000, dia buat everyday beribu-ribu. So they have to do sampling or testing. Okay, mula-mula what do they do? Take periodic samples from a process. Let's say proses tu 1 hari untuk siap the whole process, dia buatlah proses. So you take periodic samples. Maybe you take sample daripada pukul 8 pagi, lepas tu you ambil lagi pukul 10, pukul 12 ataupun you ambil every 3 hours ke, right? And then plot the sample points on a control charts, right? Kita plot, nanti kita will learn how to calculate, how to do the control chart, and then you mula-mula collect data, lepas tu kita plot the graph, and then kita determine if the process is within limits. Okay, sama kita kan, I told you there's variation, so ada buffer, right? Ada ruang. That means kalau macam kita cakap macam kita jahit baju kan, kalau macam ada 5 cm, kalau baju 5 cm boleh kot cm kiri kanan yang kita terlebihkan ke kurangkan ke, that means it is within limit. Kita ingat this word within limits. Dia antara, so let's say baju dia 20 inci, saya tak tahulah 20 inci, okay, tapi kita lebihkan sikit, belah kiri kita lebih lagi 21 1 inci, so the whole thing will be 22 inci. So that means still boleh gunalah kain tu, but dia antara tu, baju-baju yang terkemudian ni kita ikut ukuran tu, tapi antara 20 ke 21, 22, tapi semua satu kiri satu kanan, so 22 inci. So kalau within that limits tu, itu kita panggil control limits. Within that limit, that means it's okay. Kalau macam dia 21.5 ke 21 ke, that means okay. Sekali kita buat baju tu dia punya size kan, limit kita 22 kan, dia punya size 24, tu tak boleh dah. I mean, it's not within the limits. So once we know that there is a variation, kita you correct the process before defects occur. Remember, this is quality tools kan, kita dah belajar. This is one of the quality tools. So quality tools, you know, use quality tools to check for errors. Kan, kita nak buang error atau limit error. Okay, SPC pun kita boleh guna. Just now if we look at manufacturing, we can also look at services. Okay, nature of defect is different in services. Service defect is a failure to meet customer requirement. Then we monitor times, we monitor customer satisfaction. Okay, service pun ada, we can use SPC to check, right, whether the service is of quality, berkualiti ataupun tidak. Kita tengok certain dimension, macam hospital, kan, kalau kita pergi hospital kan, we have to wait very long kan, macam like we look at timeliness, we look at responsiveness, we look at accuracy, right? Macam responsiveness, macam mana, how cepat kita dah tunggu lama, lepas tu cepat tak kalau kita dah dipanggil nama tu, dia buat dia check kita kan. And then accuracy, right? Accuracy, betul ke tidak yang diagnosis yang dia bagi tu, okay? Obat yang dia bagi tu, right? Baru ni petang tadi saya dapat call daripada postman mengatakan, adakah saya duduk di Pendang? Sedangkan saya ada di situ. Because saya ada beli barang, and then supplier tu dia hantar postcode betul tapi alamat di Pendang. Okay? That means it's not, the service doesn't meet customer requirement. So besok saya terpaksa pergi Jitra ambil kat post office barang tu. It's very inconvenient lah benda-benda macam tu. That is for service. Macam grocery stores pun ada check-up time, stocking, cleanliness, kan? Airlines, luggage kan, kalau you naik flight, okay, mungkin you sampai on time tapi nak tunggu luggage lama. See? And then waiting times for you to board the plane, nak naik ada dia delay ke tidak your flight. And then courtesy, kita di sana, di dalam flight kita nak tengok the courtesy of the pramugara, right? And then for fast food restaurant, kita also tengok waiting time, kita tak nak tunggu lama sangat kat restoran. And then we also look at food quality, and then we also look at the cleanliness, kan? This is the SPC as applied to services. Okay. Ni gambar dia, right? This is a process control chart. Okay. This is the process average or the mean. Kan when you look at the slide, they will always say that around the mean, within the mean. Ni mean dia, right? This is the upper control limit ataupun dia panggil UCL. Okay. This is the lower control limit or LCL. I think kalau macam siapa yang dah biasa, yang dah ambil paper operation management, you will know how to calculate this, okay? I think you learn in operations management as well. Okay, constructing a control chart, decide what to measure or count, collect the data, plot the samples macam tadi lah. Okay, so yang kita nak determine apa? No sample points are outside the control limit. Most points are near the process average. Dia nak kat sini. Near point-point tu dia nak kat sini. This one yang luar-luar ni kita we don't want. There's 1 point above the upper control limit so that we show that the process is not in control. So if about equal number of points are above and below the center line, points appear to be randomly distributed. Right? Normal distribution, you pernah dengar kan bell curve ni yang famous ni? So, bell curve ni, okay, area under the curve is equals to 1. If you learn statistics, you will know that all these are sigma. Sigma 1 yang macam gini ni sigma. Sigma 1, sigma 2, sigma 3. Mu. Mu is mean equals to 0. Tengah-tengah ni is 0. So this one will be 1. This one will be negative 1. Right? Okay. Z. Area under the curve usually is Z. Okay? Z is kalau macam if they give you a question for control charts, kalau dia tak cakap apa-apa, that means Z value is 3. That is standard. So it compromise between sensitivities and errors. Berapa ni? Oh, dah 4.5 dah. Okay. Look at this. Remember tadi kita nampak upper control limit and lower control limit, right? This is how they put the bell curve tu macam ni. You see? This is the bell curve. So this is 3 sigma plus 3 sigma. This is the negative 3 sigma. Okay? Upper control limit, lower control limit. This is the medium. This is the average. Ataupun center line lah apa macam-macam dia orang panggil. Right? This is how macam mana kita nak tengok, kita understand. That means all the points, apa data-data yang kita collect tu is must within these two line, within 3 sigma. See? That means 6 sigma kan? 3. Okay? So, okay, kita dah tahu tu, sekarang kita nak tengok data. Data ni ada 2 jenis. Right? For you to know, memang kalau dalam exam, they will give the formula. Tapi you kena tahu what kind of data it is for you to use the formula. Sebab semua data, they will have different formula. Formula kan dia bagi, even bila you kerja, they will give you the formula. You don't have to hafal pun. Tapi you must know what kind of data it is. Okay? So dalam SPC ni, dia ada 2 types of data. One is attribute data, one is variable data. Okay? Attribute data ni, macam mana dia measure? Dia measure dengan discrete choice. Discrete choice meaning that sama ada dia bagus atau tidak, good or bad, yes or no, girl or boy. 2 je dia punya decision. Ataupun dia count. Okay? Kira. You boleh kira berapa banyak errors atau berapa banyak defects. Berbeza dengan variable data, you nak tahu senang je pasal the product characteristic can be measured. Okay, dia ada point-point, dia ada apa nama dia? Dia ada fraction lah kalau nak kira. For example, seperti length, right? Ketinggian, berat, time, velocity, mass. Itu semua, that kind of data is called variable data. Okay, I hope you are alert on this. Okay, maybe the next class ke, the next subject you ambil next year ke, mungkin they use this kind of things. So at least you already know. Okay, there are two types of data: attribute and variable. Okay, for attribute data, for us to measure, we use the P charts ataupun the C charts. Berbeza dengan variable data, we use X bar chart dan R charts. Okay. Okay, I hope it sink in ingat masuk semua kat dalam, right? Okay. P charts. Okay, I think kita sempat belajar. I hope I nak ajar semua, tapi I don't know whether we have time. Okay. Sekejap ya. Tadi pun saya dah ada kelas 2 jam. Tak ada suara. P charts ni, P kan, nama pun P. So it's percentage defectives. Kita tengok berapa banyak percentage yang defect lah. Error, kerosakan. Okay. So the item is sama ada baik, good or bad. Okay. Macam tu dia measure. Right? C charts ni, C, the word C, that means you count. Let's say kalau macam you tengok kereta, okay, kereta kat pintu kereta tu, you nak check berapa banyak kemik ke, berapa banyak cala ke pada kereta, pada the car. You can count. That means boleh kira. Okay? I repeat again. P charts, you look at percentage defectives. The item is either, dia ada discrete choice, the item is either good or bad, male or female, yes or no, macam tu. Okay. C charts count the number of defects in an item. Okay. I hope you buka mind you to understand this, right? Okay. The formula for P chart. Okay. UCL tadi kita dah cakap upper control limit. LCL is the lower control limit. P, okay. Formula dia UCL is equals to P plus Z sigma P. Okay. LCL pula P minus Z sigma P. Okay. It's not P, it's P bar, I think. Yeah. Z is the number of standard deviation. Okay. Yang tadi standard deviation, apa ni yang plus 3 or minus 3. Tapi kalau macam it's not mentioned, just use 3. Okay. Z is the number of standard deviation from the process average. P bar, ni semua ada bar ni. Dia tak tahu kenapa hilang tak. P bar, sample proportions defective kan? Because you know P is percentage, that means it's proportion and estimate of the process average. And sigma P is the standard deviation of the same proportion. So you look at the formula for sigma P is this. Square root of P bar 1 minus P bar divided by N. Yeah, N divided by total. Okay, jangan takut. So we're going to look at the apa ni contoh Kita tengok. I hope that you will do this together. Kita tengok contoh dia. The Western, this kind of question kalau untuk P, okay, P chart. The Western Jeans Company produces denim jeans, right? The company wants to establish a P chart. Oh, ni senang lah pasal dia dah beritahu you, right? A P chart to monitor the production process and maintain high quality. Western believes that approximately 99.74% of the variability in the production process corresponding to 3 sigma limits. That means dia beritahu lah Z ni you kena read Macam you buat soalan soalan problem lah kan masa exam tu kan. It's random and thus should be within control limits. Whereas 0.26% of the process variability is not random and suggests that the process is out of control. Okay. So you dah dapat dah, dia nak suruh buat P chart sigma Z dia pada 3, right? So the company has taken 20 samples, right? 20 samples, one per day for 20 days. That means 20. 20. Each containing 100 pairs of genes. See, N tadi ada formula dia kan? N is 100. So hari pertama hingga hari 20 dia ambil 100, 100, 100, 100. Right? So bila dia tengok, okay, for the first day, there is 6 defect. Dia tengok seluar jeans tu, ada macam mungkin colour dia tak itu ke apa kan. So, 6 defectives. Second day tak ada pula. Third day 4. For hari keempat banyak ni 10. So, dia ambil sampai 20. So, you total up the number of defectives, 200. Daripada hari pertama hingga hari yang ke-20, right? So proportion defectives ni kan, because they want you to develop a P chart. Kalau dia ada tulis percentage ni, kalau dia tak tahu cakap pun, you know it's a P chart. So you kena buat percentage, proportion defectives. Proportion defective is macam ni. Macam ni dapat 0.6 ni. Sometimes dia tak bagi. It just bagi you these two numbers saja. How do you find the proportion defectives? Anybody? How do you get 0.06? Siapa nak tolong? Siapa nak cuba? Come on. Yeah, you say, your friend says 6 divided by 100. N is 100. Right? So that's how you get. For every sample for 20 days, you get the proportion defectives. Right? Okay. Kita tengok kat sini ya. Number of defectives 200 tadi. Sample 20. 100 pairs of genes. So this we already got the proportion defectives because 6 divided by 100. Because every day you take 100 samples, right? So this is the formula. P bar, okay, nak dapat P bar ni. Sebab formula dia is P bar ya. Tadi tolong, if in your slides tak ada bar tu, you draw atas. P bar plus Z. Sekarang tadi dia dah substitute. This is sigma P kan? This is the formula for sigma P. Macam mana dia dapat P bar ni? P bar is total defectives divided by total sample observation. Okay. Sekali kita pergi ke belakang. Total defectives, total sample of observation. That means 20 hari, kita ambil setiap hari, we take 100 pairs for sample. Okay. So, 200 divided by 20 times 100, where you get 0.10. Right? So, you know that P bar is 0.10. So, you substitute it into the formula. Okay, Z is equals to 3. Tadi the question have mentioned, right? You put it in 0.10 bracket 1 minus 0.10 over 100. This is the square root of that. Then you will get upper control limit to be 0.190. You need to get the control limit. Bukan you saja draw kat on your graph. You must calculate to get the control limit. Formula dia sama je, cuma plus dengan minus, okay, for lower and upper control limit. But sometimes student tends to get confused, okay. So dah dapat P bar minus Z square root of P bar 1 minus P bar over N. Okay, so for the lower control limit is 0.010. Okay, ni dah okay lah, you dah dapat the control limit. Of course, the center line is this, P bar. Okay, that's the P bar. So I prefer to draw on the whiteboard, so kita belajar kan. So here, we have to make do. Okay, then you plot. Remember, tadi 0.1 is the P bar. Saya pun tak ingat ni. 0.01 dengan 0.19. Okay. 0.19 is the upper control limit. 0.01 is the lower control limit. This is the P bar. So kita plot. Okay. Remember you get the proportion defectives, right? Here, that's where you plot. You plot. You tengok. Okay. Is the process in control or out of control? Ada tak points yang above or below the control limits? Ada tak yang very erratic? That means dia ubah tak tentu hala. Remember kita nak dia random aja, sama aja. Yang kita nak tangkap ni, yang kita nak identify is non-random variation. Okay? So what do you think? Let's see. Is the process in control or out of control?
Out of control.
Out of control, right? Good. Because you see, satu, because the point is here. Right. Yang daripada bawah ni macam dia tak apa? Dia tak random, tak sekata. And then the number of points above or below the average is maybe tak sama. Dia kena lebih kurang sama lah. Right? Okay. That is the P chart, how you construct the proportion defective. Okay. Now we go back to the C chart. Okay, tadi P chart kan, P chart yang mengira the percentage or the proportion defectives. C ni dia kira apa tadi? What kind of errors does C measure? Kalau nak guna C chart. Ingat tak? What kind of errors? What kind of defects? Countable, yeah. She say countable. Defects that can be that you can count, right? So formula dia senang. It's much simpler than the P chart. It is UCL equals to C bar plus Z sigma C. Tapi sigma C ni dia punya formula is square root of C bar. Okay? Ingat C bar, P bar, X bar tu semua average. Right? Okay. C chart counts the number of defects in an item based on the Poisson distribution. Okay. C is equals to number of defects in an item. C bar is equals to total number of defects over number of samples. Right? This is the formula tadi we have looked at. Okay. Right? Number of defects in 15 inspection sample. That means of hotel room. Okay. Dia kira defects in 15 inspection samples of hotel room. Mungkin hotel tu mungkin in one hotel dia ada about 200 rooms. So, they take 15 at random, pilih, tengok dalam bilik tu, let's say sebelum customer go inside the room, everything should be ready. That means bantal should be nicely taruh betul-betul. The cadar, is there enough coffee, tea, enough dia punya sabun semua. So they look for defects in the hotel room, right? So here they take 15 inspection samples, that means that means 15 bilik, so 15, right? Number of defects, remember C is counting. So in room 1, there are 12 defects. Room 2, there's 8 defects, and room 3, there's 16 defects. And room sampai room 15 is 15 defects. So if you total up, is 190 defects. Okay, so we look at this. C bar formula dia is total number of defects over total number of sample, right? So you get 12.67, right? So masukkan dalam formula C bar plus Z sigma C. So you will get 23.35 for the upper control limit, and lower control limit is 1.99. Okay, so you plot. This is C bar, tadi 12.67, kan? This is the upper control limit here, and this is the lower control limit, right? So judging, okay, you tengok the graph, is it in control or out of control? Right? In control, yes. Yoshi say in control, Lily, she say is in control. Right? Tengok, even the graphs is very nice. Right? The way you plot it, see, it's very nice. So dia tak ada continuously going up or continuously going down. See, this is a very good graph. Okay? So the process is in control. Right? Okay. When the process is in control, what you should, let's say if you ask in the exam, okay, process is in control ke, out of control ke. So what you should do is, bila dah cakap, okay, the process is in control, why? You must explain. Okay, macam kita buat differencing plane tu. Why? Because the you can say that the points is all within the control limits. Kalau dia out of control, kenapa? Kenapa out of control? You say maybe they pandai lah. It depends on the question, kan? Of course they will give a story, blah blah story tadi, jeans ke apa ke yang rosak ke, yang tadi for the P chart tadi. Mungkin you can say that the C chart, so because maybe machine ke, machine rosak ke, atau material tak bagus, so you must give something, right? Kenapa it is out of control? Kenapa it is in control? You read your book, dia ada beritahu, okay, kalau macam out of control, what are the causes? Baca, right? Okay, now tadi kita dah tengok attributes data, ni kita tengok variable data. Okay, variable data yang macam measurement, can be measured. Okay, macam height, weight, velocity, time. Okay, so for this kind of data, kita use the mean chart ataupun dipanggil X bar chart. Right? Mean, as you know, it measures the central tendency of a sample, and then they also use the range chart, measure the amount of dispersion in a sample. Okay, so kita tengok each chart measures the process differently. Both the process average, okay, this is the process average, and the process variability must be in control for the process to be in control. Yang ni, data ni dia perlu dua chart untuk menunjukkan sama ada the process is in control or out of control. Okay, this is the formula. UCL is equals to X double bar, okay? Please be alert. This is X double bar plus A2 and R. R is the range. A2 is a constant. Okay? LCL is equals to X double bar minus A2 and R bar. Okay? Where X double bar is the average of sample means. you dah dapat sample mean, but you do another average. That's why it's called X double bar, right? Okay, this is the mean. Sorry, mean pula. Ya Allah. This is the constant. Okay, depends on the sample size, right? If you're just the sample size for this table, sample size from 2 to 12. Okay, so if your sample is 5, that means your A2 is 0.577. Okay, this one is the constant for the R chart. Okay, we look at it. Sama lah. Kalau macam sample is 5, that means D4 is 2.115, D3 is equals to 0. Okay, this is a table, right? Usually they will give you or they will tell you what is A2, what is D4, D3. Okay, right. So, observation of a slip ring diameter. Right? So dia ada sample K. Right? 1, 2, 3, 4, 5. Okay. For day 1, they take 5 samples. Okay. This is, then you take the average. Okay. Range. How do you get 0.08? How do you get 0.08? Can you think? How do you get? Of course, I'm sure all of you dah belajar range kan? How to get range value? How do you get 0.08?
The higher values minus the lower values.
Yes. So for here, the highest value is what? For number 1. Okay, sample 1. The highest value is what? Which one? 5.02, right? The lowest value? 4.94. So if you subtract 5.02, if you subtract 4.94 from 5.02, you will get 0.08. That's how you get this value. This is range, okay? This is not the R bar range. This is just the range. But this is the X bar. Okay? You get the total X bar. Here there is the total range. You do that for all the samples. Okay, the formula R bar is equals to summation of R over K. Right? K berapa? How many is K? I know it's 10, but where is it? Okay. CK 10. Right? Maybe 10 days or 10 weeks, I don't know. Say they make 10. Right? So K 10 summation of R is 1.15. Remember this figure? Summation of R. Right? To get R bar, you put summation of R divided by K, which is you get 0.115. Right? Okay. Got it, Sink in, let all sink. Then we look at X bar. Sorry, X double bar. X double bar is equals to summation of X bar over K. Summation of X bar is 50.09. Remember, this is the whole thing, the whole 5 occurrence, and then they take the average. So this is X bar. And then to get X double bar, okay? X double bar over K, that means X double bar is 5.01 cm. Okay? Right? So kita tengok UCL. UCL formula is X double bar plus A2 over R bar. You have R bar, you have X double bar, A2. Okay? A2. Macam mana nak dapat A2? How do you get 0.58? This is from the table just now. This is the value of A2. How do you get 0.58? Which one do you choose? N equals to what? Come on, guys. N equals to what? N equals to? So Hannah said N equals to 5. Right? So 0.577, you put 0.58. Because, see, this is 5. 1, 2, 3, 4, 5. This is N. This is K, right? It's different from the X bar chart, right? So 0.58 times 0.115 or 0.58, 5.01 minus 0.58 times 0.115. Then you get the upper control limit and the lower control limit. Okay, look at this. Right? Okay, this is X double bar. Okay. In the exam, right, if they ask you to draw any chart, okay, P, C, ke banyak lagi chart. There's a lot of charts, but we are just going to learn these 4 charts, okay? You must write down the UCL, the LCL, and the middle. Okay, you must write down. So you plot, right? Then you must also do the R chart. Tadi kita buat X chart. The formula for UCL is simple. D4 times R bar, LCL is D3 times R bar, right? R bar kita dah kira tadi, right? K is the number of samples. Okay, so you have, just now we calculate the R bar already. D4, okay? D4 is 2.11, betul tak? I want you to show the table just now. 2.11. So just now the N is 5, right? 2.11. D4 is 2.11. D3 is equals to 0, right? So, okay. So, the upper control limit is 0.243. The lower control limit is 0, right? You retrieve the factors here from D3, from the, what do you call, from the table just now. Then you plot, okay? You plot the R bar, UCL, LCL, okay? So, sorry. So you think is the process in control or out of control? Come on, guys. In control or out of control? In control. Yes. You see, both charts, yeah. Kalau macam untuk R chart and for this, for the apa nama dia, variable data, you must look at both charts together. If only one of them is in control, another one out of control, that means out of control. So here, both are in control. Okay, this is the pattern, right? So some patterns, sample observation consistently below the center line. Here you can look at the book, okay, have better explanation. So bila you draw your control charts, you will know sama ada it is in control or out of control. I can't remember which page. Which page is it? Oh, on page 315, okay, they show you a lot of patterns there. You have a look. The patterns for the LCL and UCL. Hmm? See? Constant naik, turun, right? Okay. So you tengok, if 8 consecutive points on one side of the center line, 8 consecutive points up and down, itu yang tadi kita tengok, 14 points alternating up and down, 2 out of 3 consecutive points in zone A but still inside the control limit, 4 out of 5 consecutive points zone A or B. Okay, you tengok ni. Dia ada zone A, zone B semua. Okay. Baru you tengok kan sigma kat mana, X bar kat mana. So you will know whether the process is in control or out of control. Okay. Attribute, you must have a lot of data. So from 50 to 100 parts in a sample. Variable, dia tak perlu banyak sangat, only 2 to 10 parts in a sample. Okay. Process average and process variability. Process average tu X bar chart. Process variability tu is the R chart. They must be in control. It is possible for samples to have very narrow ranges, but the average might be in control limits. That means within the upper and lower control limits. If possible for sample average to be controlled, but ranges might be very large. It is possible for an R chart to exhibit a distinct downward trend, suggesting some non-random cause is reducing the variation. Okay. Okay. I just send some work to you. Okay. So since we are not going to have class for this Sunday, so for that class, okay, you submit your work. I have only put for the P chart and the C chart. Okay, I will put another work for the X and R chart. Okay, it will be in your classroom, right? You do this what you call these exercises, right? 1, 2, and 3. Okay, the X and bar chart I haven't put it up yet. I only have put up 2 for P and C chart. Okay, look at this one. I want you to do this. Okay, this is for your, at least there's your for the class that we're going to miss on Sunday, next Sunday. Okay, so please submit it before 4 o'clock on Sunday. Okay, you must draw, okay, and please put it in PDF. Kalau boleh, put it in PDF, right? It's easier to mark if it is in PDF and if you put it in the classroom. But tidak, I have to convert your files, right? Any question? Any question? I will also give you another slides. On. Never mind. We will learn it on next Wednesday. You have some time. Okay. Cuma I want you to take a look at your individual assignment, your group assignment. Okay. Make sure you update, and when the time for submission, please submit on time. Okay. Any question? Actually, once you know the concept of this SPC, it's not that difficult. Okay? It's not that difficult. You just make sure that you know the formula, right? Formula will be given. Just you know the data, which type of data to use. Okay, to which formula. Okay, any other question, guys?
Doctor, we just submit it on Google Classroom or both?
Google Classroom.